Hi, hello, welcome to another math lesson. We're going to be starting Unit 6 today, and we're going to start with a ratio of line segment and how to find a coordinate point given a equation. So during this lesson, you're going to learn how to find the point on a directed line segment between two given points that partitions the segment into a given ratio. So partitions into a given ratio, those are the key points there. Let's get going. Vocabulary: a coordinate or coordinates are two values that together represent a location. On a coordinate plane, a coordinate point is a point that is represented by an x value that describes where the point is located on the plane. So this point is usually an x, y value. Remember, I like to talk about this as like the address of the point. A ratio is the relative size between two values with sizes a and b. The ratio can be represented as a to b or a over b, both meaning the same thing. A line segment is a line that has a beginning point and an end point. A directed line segment is a line segment that begins on some point and continues in a defined direction towards an end on some point in the coordinate plane. So the key here between a line segment and a directed line segment is a defined direction. Alright, so partitioning a directed line segment. So we can actually create a ratio on a line segment by finding or placing an intermediate point on the line segment. So that just means I have another point like so. The directed segment below is defined in two different ways. I can say I'm starting at E and going to F, and I would say that as EF. Or I could say I'm starting at F and going to E, and that would be FE, depending on the direction you're going. So you have to be very careful about which one goes first, because it is going to change and it is going to affect your answer. Alright, so when I'm dividing this directed line segment, so when we cut it into two pieces, we place a point. So in this case, we have point P. So when the segment below is described as AB, so I'm starting at A and going to B, then the ratio would be 2 to 3, because I start at A, I go 2 spaces, and then I finish at B, so it's 2 to 3, okay? But if I describe it as B to A, so I'm starting at B, we have to reverse that, 3 to 2. I'm getting my ratios by how much bigger one section is. So I'm going to highlight these here. So I have one section here, right? And another section right here. And when I start this, and this is something that I see a lot, is I start at A, so say we're doing this A to B one, I'd go 1, 2, that's how I get my 2 value. Start at P, 1, 2, 3, there's where I get my 3. Now you try. So find the ratio created when AC is partitioned by B. So I'm starting at A. Here's my start. Here's my finish. So I get 5 to 3. There's my ratio. Alright, so we'll sometimes be asked to find a point on a directed line segment that's not on a coordinate plane and is not horizontal. So what that means is I'll have some angle, or I'll have some line on a coordinate plane. And we'll be given 2 points, 2 endpoints, okay? And it'll say partition this line 2 to 3 or something. And we'll have to find out where that would be. Okay, so we'd have to find whatever that point B would be. And this is the equation we're going to use. A divided by A plus B multiplied by x sub 2 minus x sub 1 plus x sub 1, comma, A plus B times y sub 2 minus y sub 1 plus y sub 1. So I want to make a point here. So what this is I'm finding a coordinate point. I have an x coordinate and a y coordinate. So I know this looks really messy, but this is really two different equations, two different parts. The blue over here is going to give me my x coordinate. And the green right here is going to give me my y coordinate. Okay? Notice they're very similar. Only thing that changes are these x sub 2 and x sub 1s. Okay, so A is the number of parts on the one side of the point. So if I'm given I want a 3 to 2 ratio, my first ratio point is my A. B equals the number of parts on the other side of the point. That's my second part of my ratio. X sub 1 and y sub 1 are the first point in the directed line segment. Y sub 2, or x sub 2 and y sub 2 is the second point. And this x sub 2 minus x sub 1 is just the change in x. Y sub 2 minus y sub 1 is the change in y. Okay. So let's look at this. Here's my example. Given the directed line segment AB, with A being at the point 2, 1, and B being at the point 8, 10, find the point C that partitions the segment into a ratio of 2 to 1. So here's my important thing. I know that I have AB. Let's graph this point. So 2, 1. So there's A. B is 8, 10. Let's see, 8, 5, 6, 7, 8. There's B. So I know I'm starting at A. That's important. We know 2, 1, 8, 10, and 2 to 1. So my A value is my first point in my ratio. There's 2. B is my second point, which is 1. X sub 1 is my first point, so that's 2. My x coordinate, my first point. In this case, my first point is A. My second x coordinate is 8. My y value is 1. My second y value is 10. Okay. Now we're going to do this in two different sections. We're going to first do the x part, then we'll do the y part. So I have A over A plus B. So I get 2 over 2 plus 1, parentheses, x sub 2 minus x sub 1. So I'd say 8 minus 2, and then we're going to add x sub 1 back in. So I'd say plus 2. And remember, we got some order of operations happening here. So I get 2 over 2 plus 1. I get 2 over 3. 8 minus 2 is 6, plus 2. Okay, 2/3 is 6. We get 12 thirds plus 2, which is equal to 12 thirds is 12 divided by 3 is 4 plus 2. We get 6. Okay, so I know my x coordinate is going to be 6. Okay, I'm going to kind of cut this off here. Now we can do the y coordinate part. Okay, well, I know this A over A plus B is going to stay the same, so I'm going to just say 2/3. Now we have y sub 2 minus y sub 1, so I'm going to go 10 minus 1, and we add y sub 1 back in. So I get 2/3, 10 minus 1 is 9, plus 1. 2/3 times 9 is 18 thirds, which gives me 18 divided by 3 is 6. We get 7. Okay, so there's my coordinate point. We're going to put that point as 6, 7. Okay, so I got 6, 7. Well, that definitely looks like it fits in with the line, right? And this portion right here, my first part, should be twice as big as this second part, which looks like pretty accurate. We did a pretty good job there. Alright, I want you to try now. So pause the video and give this one a whirl. Given the directed line segment CD, with C being -1, 2, and D being 7, 14, find the point P that partitions the line segment into a ratio of 1 to 3. Okay, so I'm going to start with graphing this. -1, 2. We have 7, 14. There's C. There's D. Okay, first we get A over, let's see, A over A plus B, so 1 over 1 plus 3, x sub 2 minus x sub 1, plus an x sub 1, which is -1. We get 1/4, and an 8 there, minus 1, 8/4 minus 1, 2 minus 1, 1. So my x coordinate is a 1. Okay. My next one I get is 1/4. See, y sub 2 minus y sub 1, 14 minus 2, plus y sub 1. We get 1/4, 12 plus 2, 12/4 plus 2. 12 divided by 4 is 3. We get 5. Okay. Now let's see how we did here. So we got 1, 5. Well, it definitely fits in the line. And then we just gotta say, is this section, how is it related to this section right here? Yeah, that yellow section is probably about 3 times as big as that pink section. Our coordinate point we found was 1, 5 to divide that ratio up. Alright, if you have any questions about this, please don't hesitate. Come and ask for help. Come talk to me or one of the fantastic tutors, and we'd be happy to help you out. Take it easy, have a great day, and we'll talk to you later. Bye.